Hi, I'm Dr. Alexandra Yeung and I'm a lecturer at Curtin University, and welcome to one of our many chemistry labs here at Curtin Bentley campus. So now that we've finished our titration, we can calculate the concentration of our tartaric acid that we have in our wine sample. So up on the board, I've just put up all our results. So we have our rough titration, and we end up doing 4 accurate titrations in order to get concordant results. The first thing we have to do is work out our average titer volume. And to do that, we take our concordant values and find the average of those. So we have 16.50, 16.45, 16.55 and 16.50. If we find the average of these, we get an average titer volume of 16.50. So this is our volume of our NaOH. Then we can actually do the rest of the calculations. So we know the concentration of our sodium hydroxide, and we've just worked out the volume of our sodium hydroxide. So to work out the number of moles, that's equal to concentration times volume. So our concentration is 0.097 moles per litre, and we multiply that by our volume, which is 16.50 mils. But if we notice that our concentration units are per litre, which means that we have to convert our volume from mils to litres as well. So if we convert our volume from mils to litres, we end up getting 0.0165 litres. So our number of moles is 1.61 times 10⁻³ moles. So this number is quite important. We can actually now use that to determine the number of moles of our tartaric acid. And the way we do that is basically look at our mole ratio. So the number of moles of our tartaric acid equals half the number of moles of our sodium hydroxide, which equals 8.00 times 10⁻⁴ moles. So that's the number of moles of our unknown solution of tartaric acid. And from there, we can then calculate the final concentration. The reason being, we know the volume that we used of our tartaric acid. That was the aliquot that we used. And that value was 20 mils. Yep. So then we can then work out our concentration now. The concentration equals number of moles over volume. So the number of moles is 8.00 times 10⁻⁴, and the volume we used was 20 mils. So that ends up being 0.02 litres, and that gives us a value of 0.040 moles per litre. The total acidity concentration of wine is usually represented in grams per litre. So we just need to do a basic conversion to convert that value into grams per litre. We take our concentration of 0.040 moles per litre, and we need to multiply that by the molar mass of our tartaric acid, 150.87 grams per mole. Our units cancel out, so our final answer is 6.0 grams per litre. This is actually within range. So most wines have an acid concentration between 6.0 grams per litre to 8.5 grams per litre. A final thing that we need to do is represent our concentration as a percentage, because often people want to know what percentage of acid is actually in the wine. So one way of working out the percentage of tartaric acid in wine is to work out the percentage of weight per volume. We work out the mass of our solute and divide that by the volume of our solvent and multiply that by 100%. The mass we have is 6.0, Our volume that we have is a litre, 1,000 mils, times that by 100%, and that gives us a percentage of 0.60%. The alternate way assumes that the density of the wine is roughly the density of water. And to do that, we work out the percentage weight per weight using that assumption. And that means we have the mass of the solute and divide that by the mass of the solvent. Our solvent is 1 litre, 1,000 mils, and the density of water is 1 gram per mil, which means that in 1 litre we have 1,000 grams in a litre. So we have 6.0 grams over our 1,000 grams, which gives us a value of 0.60% as well. And that's the end of our calculations. We hope you enjoyed learning how to determine the acid content in wine today and found it knowledgeable. If you'd like to find out more about studying chemistry or a science degree at Curtin, head to study.curtin.edu.au.